Hi everyone, I am Bhavna, 4th semester Electronics and Communication Department of Sri Venkateshwara College of Engineering. Today, let us deal with the subject Biology for Engineers. In that, let us deal with the topic Eye as a Camera. Automatic detection of camera translation in eye video recording using multiple methods. The introduction of this topic are video recording of eye movement combined with software to extract the direction in which the eyes are looking has a potential to improve eye movement studies by reducing invasiveness while providing high temporal and spatial resolution. We recently used a video style in a study of eye movement as a function of gravity level aboard a NASA KC-135 aircraft. The basic methodologies of eye as a camera are the first one was framework for eye imaging. We developed a framework to understand the problem. We assume one camera for each eye and the both cameras are rigidly coupled on a frame that sits on the head. We assume that any rotation of the images due to tilting of the headset is negligible but rather presents as apparent differential translations of the two eyes. The second methodology was determining translation using cross correlation. Here, the block diagram represents determining the translation using cross correlation. Eye horizontal, eye vertical, and eyelid, they both all three together in the left eye, they passes through the physiology to create a planar image of eye region, which give rise to camera to a eyelid detector. In the right eye, eye horizontal, eye vertical, eyelid, they all passes through physiology to create a planar image of eye region to give rise to camera eyelid detector. This is a framework for eye imaging. This is the second methodology which tells us determining the translation using cross correlation. The third methodology was improving cross correlation using a prior physiology knowledge. The images used for cross correlation include components of the eye that move independent of camera shift. This includes the pupil, whose position in the image is the primary variable of interest in determining eye position. Thus, the cross correlation peak can be shifted by movement of these components without actual camera shift. To reduce this article, we identify the regions that are known empirically to have independent movement. The intensities of these regions are smoothened using the intensity of boundary region. The fourth methodology was determining the translation using the upper eyelid position. This method uses a set of image processing techniques to find the upper eyelid. Although the algorithm incorporates the curve fitting, the final result is a set of points that define the border of the eyelid and thus provide a more accurate measure than that of the approximately fit curve. The algorithm consists of the following steps. Use the same processing as described above the remove the pupil and LED reflections. Perform the horizontal Gaussian smoothing to reduce the effects of bleams and eyelashes. The next methodology was determining translation by creating a eyelid template. This method combines the first two. A genetic eyelid template is created based on the eyelid detection in all the video frame, and this eyelid template is cross correlated with each video frame to determine the camera translation. In the initial pass, a eyelid counter is found for each eye video frame. Least square estimate is used to make this assemble overlap maximally. After overlaps are rejected, the curves are averaged to form the eyelid template. In the second pass, the eyelid template is cross-correlated with the negative of each image frame. The negative is used because of these particular images. The result of this topic was error in determining the camera translation for a video. Here we have the following methods called image cross correlation, eyelid tracing, eyelid template horizontal constant, eyelid template 20% ejection. For this, it shows the result of both left eye as well as the right eye of our particular eyes. So these are the actually values for the image cross correlation. We have the left eye as 16.0 pixels, and for the right eye we have 18.6 pixels. For the eyelid tracing, we have 13.2 as left eye, and we have 10.0 for the right eye. For eyelid template, we have 2.67 for the left eye and 1.37 for the right eye. And for the eyelid template, the same thing it follows for both the things. Actually those values tells us a region for the left eye as well as the right eye. The discussion of this topic includes this vertical translation, how the eyelid tracing, image cross correlation, eyelid template constant, interactive marketing. It shows a graphical representation to estimated vertical camera translation in a video using the different methods. So it is a discussion of the topic eye as in camera. So it shows the graphical representation including all these topics like eyelid tracing, image correlation, eyelid template constructed, and interactive marketing. So it actually deal with the particular topic using the graphical representations. Video frame subject towards the x-axis as well as vertical translation towards the y-axis. The conclusion of this topic includes these techniques accurately compute the differential movement of video eye tracing cameras, providing a solution to an important problem. The mean error of the best method is 1.3 pixels, which is less than the 3 pixels necessary to discern the small eye movement. Current red blocks to video as in standard for the eye movement studies include the temporal speed, spatial resolution, and headset movement. The first two issues are overcome by multi-megapixel cameras with the frame rates in the kilohertz range that are currently base released. Acknowledgement. We thank Dimrit Bitout and Sarat Wing for advising about the image processing algorithms. We appreciate the participation of our test objectives subject. So these are the references for this topic eye as in camera, AH lag, D detector. All these persons are the researchers. They are the references for the topic eye as in camera. So these are the main references which have framed the methodologies as well as the main topic regarding eye as in camera. So thank you all. Thank you for the session.